Hello and welcome once again to another video from the only channel that you need to not only survive the current apocalypse, but actually enjoy it. And today's video is going to be the first in a series that I am producing in order to debunk flat Earth. Now, I've discussed doing this with a very close friend for quite a while, and his advice is don't involve yourself. It's not your fight. You've got more important things to do. The videos you're doing about the Bible are absolutely essential. Videos about exposing flat Earth are not. It's not important. And really it isn't. And I don't care. There's a lot of things that I believe in wholeheartedly that people call conspiracy theories, but they're not important. There's no reason for me to delve into that, because all that does is that puts me into a group of what the world perceives as lunatics, and it makes the things I say about the Bible have less power. So I don't want to take on anything that's going to get me in trouble and just cause problems. But with flat Earth, it's a little bit different. You know, the whole reason for this could be that the flat earthers just want me to waste my time doing this so that I won't do the more important things. But we're not just talking about my time here, we're talking about my subscribers, because I made a video series a while back called Written in Stone about the changes that have taken place in the Earth's calendar. And as part of that series, I had to explain some very basic facts about how the Earth and the Sun and the Moon function together in order for the information in the Bible to make any sense. And so, you know, whenever I do a groundbreaking series like that Written in Stone, or the All-Seeing Eye series I did, or the Angels and Men series that I did, I get, you know, a lot of different kinds of comments, but in general you get 12 comments from people saying, "Oh my God, you have taught me something that the churches have not taught me in my entire life. I am so happy to have someone explain the Bible to me in a reasonable way that I can understand. You have rescued my faith." I mean, there really are comments that are just that powerful. People who come to my channel and appreciate the information so much that they write things like that. Of course, you've always got about 50 people that just simply say thank you. I go back and write you're welcome. But then on the other end of the spectrum, you've got about 12 people who come on there. They've just listened to the most important information they will ever hear in their life about the Bible. And the comment they leave is, "This isn't true. The earth is flat. The Bible says the earth is flat. You're lying to people. You're misleading people." That's easy enough to fix. You block them and you delete them. But it really isn't, because I think the last time when I did that Written in Stone series, and you may be one of the people that got this, I had one guy or woman that was coming on and going to each comment and writing, "The earth is flat. You know, it's been proven that the earth is flat. This man is a false prophet." And it's not like, if you really watch my videos and you believe them and you understand that they're real, then that stuff may or may not affect you. But if you're like me, you're going to want to find out why in the world do people believe that the earth is flat. You should want to find out why that people believe that the earth is a sphere. I mean, it's the world around you. You should want to understand it. But a lot of times it's hard to figure out how you can understand it, because the earth is, you know, we're on it. It looks flat. The only way for us to actually see for ourselves that the earth is not flat is to go 1,000 miles up in the air, which we can't do. And so what we have to do is see if there's any way that a simple man with very few resources standing on the earth can figure out what the shape of the earth is without any information from a flat earther or any information from the Empire, which teaches that the earth is a sphere. Now, we can't cover everything that the flat earthers teach in one video, because, you know, if you go out and look, there are hundreds of, maybe thousands of flat earth videos out there covering all kinds of aspects of the teaching. It would take weeks of me standing here talking to cover all of it. But we can cover one thing at a time. And so what we're going to cover today is satellites, because, I mean, man-made satellites orbiting the earth, because for whatever reason, the flat earthers have decided to create this entire doctrine about satellites not existing. And I guess it makes sense. You know, if they're teaching that the earth is flat and the Empire is teaching that satellites circle the sphere, then if they're going to accept that satellites exist, they have to teach how satellites work on a flat Earth. You know, because a spherical Earth has some kind of science associated with it as to why satellites stay up in the air. Flat Earthers wouldn't be able to incorporate any aspect of that into their teachings. So we're going to look at why we can know that satellites are not real, and we can test out whether or not those things are true or not, because I have been told by flat earthers in person, in private messages, that you cannot see an object from 250 miles away, because that's about how far these satellites are that we can supposedly see. They're about the size of a microwave or a refrigerator, and sure enough, if you're looking at them, then you've got to explain that. Why in the world can we see something the size of a refrigerator for 250 miles away? Well, the teaching is, and there's several aspects of this, the teaching is that sunlight bouncing directly off of these things is really, really bright. So it's not looking like looking at something that's sitting out in a field. This is something that is up there and in the vacuum of space, being directly affected by pure sunlight. That makes sense. I mean, it really does make sense. And there's a reason why this would be true. Like my brother, my brother lives 250 miles away. That's why it's a good thing to mention my brother. We'll draw this out. And these are satellites that are 250 miles away from the Earth. But there are other satellites that are up here, supposedly. Now, the Empire says that they're there, but that we can't see them because they're too far away. Because, you know, just like the flat earthers say, you can't see something the size of a refrigerator that's 2,000 miles away. But according to flat earthers, you can't even see things that are 250 miles away. Well, anyways, let's say I live here, and my brother lives here. Let me see if I can see that on here. I may have to blow this up a bit. Yeah, I can't see that. No, I'm going to have to change that. All right, so let's make this bigger. Okay, yeah, it looks better. There's me. There's my brother. I think I probably better do better than that. Look, here's what we'll do. This little area right here, I'm going to blow that up across the whole screen. Okay? That makes good sense. Just have to understand that we're not going to be looking at the whole Earth. We're just going to look at the land between me and my brother. So let's say that's the Earth. Now, I'm here. In fact, I'm going to put myself right there. Say my brother's right here, right? I can't see my brother's house. Now, there are reasons I can't see my brother's house other than just, I mean, it's not just one reason. There's a lot of reasons. One thing, remember the Earth is round. I know this looks flat, but that's just a matter of perspective. You know, 250 miles, this area, and I don't even know, so please don't quote me. And don't try to tear me apart because I don't know what I'm talking about. This is a curve. Doesn't look like a curve, but that area right there has probably got a 1 mile tall lump in it because of the curvature of the Earth. So obviously, if I'm looking at my brother's house, I'm not going to see that. But aside from that, there's a lot of trees between me and my brother, and houses and radio towers. And another thing is pollution. And I don't mean pollution that's bad. I mean just it's air, oxygen, just oxygen itself, carbon itself. And those things are, you know, they're real. Gases are just as real as liquids. Liquids are just as real as solids, and they support things. So if you do have air pollution, smoke, it'll stay in suspension within that atmosphere of oxygen and carbon and nitrogen and all that kind of stuff. But then there's also just humidity. You know, on a day when the humidity is at 0%, you can see a whole lot farther than you can on a day when humidity is just 50%. So just even humidity, suspended water particles in the air. And in fact, they tell us that on average you can see on a clear day low pollen count, no air pollution, zero humidity. You can see about 12 miles. And I know that it may seem like you can't test this out, but you can. I mean, it's not that big of a deal. Even if you have just a regular, decent $30 pair of binoculars, if you go out and try to look 12 miles, your binoculars will allow you to see that distance or to see that something is there, but you're not going to see any details. In fact, I can tell you from personal experience, even just from 6 miles away, things are going to start looking cloudy. And I'm not telling you this, I'm not just making this up. I had the experience of being able to touch what's called the big eyes on my ship. The ship I was on had something called big eyes. Just a pair of binoculars. Look, everything like a regular pair of binoculars. You hold them in your hand like this, you look through them, and you can see things. The difference being that the big eyes, and every ship in the Navy has them, probably every commercial ship, they're mounted on this big iron stand that's permanently mounted on the ship. It's just like super solidly fixed mount that doesn't move. The binoculars are mounted on top, and like they're this big until you get out to about here, and they're that big until you get out to here, and they're that big. You get out here and they're like that big. These things have, the lenses in them are huge. And one time they asked me to give a tour, all day, to act as a tour guide because of family day or whatever. So we didn't have anybody on the ship. I was taken around and shown what I was supposed to show them. And one of the things I was supposed to show them was the big eyes. Well, I could look down the pier to the end of the pier, which is maybe 1,000 feet long. And I could see the gate where they were letting people in, and there was a family standing there, and I knew they were going to eventually be at the ship, and I would have to go greet them and bring them around. But I remember looking at them through those binoculars, and they looked like they were standing right next to me. And I mean, they were crystal clear. Those binoculars are good. But while I was up there, I turned to look at the city out over the water, and it was maybe about 5 miles. And I could look at a house, and the house was so huge in those lenses, but you couldn't see any details. It was like there was windows, you could tell there were windows, you could tell what the roof was, you could even see like the mailbox, but you couldn't see any of like the numbers on the mailbox. You couldn't see that. You couldn't see like if the house had shingles on it or just a flat, smooth roof, because there was enough particles suspended in the air over the course of those 6 miles to make visibility much worse than what it would be right next to me. And in fact, if you looked, say, 20 miles with the binoculars, you're not seeing much of anything. It's easy to see why they say that you have about 12 miles visibility, because even in the best binoculars, you cannot see through solid particles suspended in air. So anyway, to get back to me and my brother, like this is 250 miles. Let's see, we'll make something about the same. That's 32 inches. Actually, this isn't going to work. So we're going to have to move my house from here. Say, what do we got here to work with? Say 20 inches. Okay, so we're going to put 20 inches between me and my brother. And that represents 250 miles. We're going to come up and do the same thing over here. And this is the reason we're going to do this. Okay, so that's like a perfect triangle. There's a website you can go to. It's called Heavens Above, and I think there's a few of them. They'll tell you where the moon is and when it rises and sets, where's Mars, where's Jupiter, where's Saturn, where's Venus, where's comets if they're out there. But they also tell you where all the man-made satellites are going to be. I mean, when you go there, if you go there, don't just click on it and say, where's the stuff, because it's going to show you, like, I don't know, the prime meridian or something. You got to put your zip code in, you got to accept their legalism, and then you got to, like, agree to that, and then click on some kind of link, and suddenly there it is. There's a chart with everything that's right over your head. I mean, you click on those things, and it'll show you like a map of the Earth and where these satellites will be going, so you know to go look for them. But in any case, my brother and I talk on the phone Fridays, Saturdays, and Sundays usually, because he is 250 miles away. We can't just visit each other. But one time, I suggested that he and I start watching the satellites together. And so I think the first thing we saw was just a regular satellite, but eventually we were looking at the International Space Station and that space telescope. Well, one night, this is real, I heard that the space shuttle was going to be docking with the space station. So I made a specific point of calling my brother a few minutes before that, and I said, man, why don't you go out in the yard and we're going to watch the space station and the space shuttle dock. All right, all right. So I knew it was coming from over here. All right. So I'm telling my brother, do you see it yet? No, I don't see nothing. Are you sure? Do you see it yet? No, I don't see nothing. I kind of wish I'd have recorded the conversation. Are you sure you don't see it? Because it's going to be out in the, you know, the northeast. No, oh, wait a second, I see something. I see something. Oh, yeah, I see something. Yeah, it's moving, it's moving. And that's how you can tell a satellite from the stars. The stars will be really bright, satellites really bright, but the satellite will be moving. The stars seem to be just dead still. So anyways, he's telling me, oh man, this thing is so huge, and oh no, here comes the other one, because you're being followed, right? It's the space station is being chased by the space shuttle. They're about to connect. And they're supposed to be 250 miles away, right? So when this space station gets about here, I'm down here going, hey, bro, can you still see the space station? Yeah, man, I can see it. Well, guess what? I can see it too. So he's like, oh, man, wait till you see the shuttle. The shuttle seems like it's brighter than the space station. So we're going across here. And all of a sudden, I can see both, right? Oh, man, I can see both of them going across. Can you still see both of them? Yeah, I can still see both of them. Now, remember, my brother's 250 miles away. I can promise you that the Empire is not putting on a personal show just for me and him. Not only that, but there's like, earth-wide, there's like 10 million people subscribed to Heavens Above, and they're not going to miss, you know, a docking between the space shuttle and the space station. Well, anyways, make a long story short, or a short story a little shorter. Let's do that. Short story shorter. There was a long time, like 15 seconds maybe, where me and my brother were both seeing the International Space Station and the space shuttle. And, you know, you think about it, and it wasn't even just that, but from the time my brother first saw it till I saw the very last part going off the horizon was probably, I don't know, 30 seconds, less than a minute probably. So we know that we were both seeing it for quite a bit of time in this area, 250 miles. He was probably seeing it 200 miles before it got there, right? I was seeing it 200 miles after I first saw it. So we're talking about 700 miles. Is that right? 650 miles? Yeah, 650 miles. So I was watching this thing travel 650 miles. And I don't know what, a minute? That's fast. In fact, the ISS, International Space Station, is exactly 249 miles up. My brother's 250 miles away. And the space station is supposedly going 17,136 miles per hour. That's 4.76 miles per second. Now, if you do the math, if I had actually took out my little stopwatch, I am absolutely certain, I have no doubt whatsoever that the numbers, this number here, whether it was 650 or 1,000 or 400, whatever that number is, the math would work. The math would work that I saw something traveling 17,000 miles an hour at the same time that my brother saw it going 17,000 miles per hour when my brother was 251 miles away. Okay, that's ridiculous. Now, here's the thing. When you look at the space shuttle or the space station, in regular binoculars that a mere mortal can afford, not them big eyes, you know, the big eyes you could probably see people waving at you. But if you're looking through a regular pair of binoculars at the space station going by, Okay, in real life, it looks like a dot. Through the binoculars, it looks like a slightly brighter dot. You know, that's another way that you can tell the difference between satellites and airplanes. Because let's see, let's say if this is 250 miles up, or 250 miles away, commercial aviation, let's see, what do they say here? 8.5 miles up is about right. You know, I think some planes fly 10 miles up, some or in general, at low altitude is, I don't know, like 7 miles up, 5 miles up, but a high altitude is 8.5 miles up. But there are commercial aircraft out there that will go higher, like maybe 10 miles up. But let's just say 10 miles up for any kind of doubters. If this is 250 miles, $10 miles up is right about there. Now, right about the time I started getting attacked by flat earthers, I called my brother, and I'm just messing with his head, right? So I'm not like really. I'm going to give you another conversation that I wish I would have recorded. I'm like, hey, bro, yeah, what's going on, man? Go out in your yard, brother. And it's like, okay, what's going on? What's going on? I want you to look up in the sky. Me and you are going to do this same thing again. It's all right, man. So he goes out on his porch. And I have another website that I go to. It's called Flight Radar 24. And it tracks aviation, commercial aviation. It doesn't track satellites, just commercial aviation. And it's real. You can do this. You can go on there and you can watch Flight Radar 24's planes are on your little map. And you'll see that plane like, man, that looks like that's right by my house. You can run outside and look up, and that plane is there, going exactly the direction they tell you it's going. So my brother's out there, right? Yeah, I says, like, look up in the sky, man. Look up in the sky. Yeah, what is it? What is it? It says there's a jet up there. Oh, man, how did you know that? So I'm watching Flight Radar 24 on my internet, and it just told me that there was a jet going over right now. And I says, tell me when you can't see it no more, right? So he's watching this jet, and he goes, I guess it's here, and then after about 5 minutes, it's there. And he goes, okay, man, it just disappeared. He says, what do you want me to do now? I said, well, just hold on. I want to see when it goes over my house. So, it's 250 miles away. I don't know. Planes are going like 500 miles an hour, so that's like 30 minutes. He goes, okay, what? He says, are you serious? I said, yeah, man. Well, how long is this going to take? I said, about half an hour. He said, I ain't got time to mess around like this. What's wrong? What are you trying to tell me? I said, well, I'm doing an experiment for flat earth people who say that this up here, this space station, is an aircraft. Because there's a dome there, and the aircraft can't fly over the dome. Or there's radiation there, and aircraft, or satellites can't fly above the dome, and satellites cannot fly in radiation, and satellites cannot fly where it's too cold or too hot, and satellites are too far away to see. And my brother's like, I'm going in. Bye. So that's a story. I hope that you can understand. And look, here's the deal. Here's the specifics on that. Let's see here. Oh, I shouldn't have erased that. Let's put that back up. Commercial aviation, 570 miles per hour, 8.5 miles up, but that's commercial aviation, right? That's the big airplanes that carry people and cargo. What about the world's record breakers? Well, one that everybody's familiar with is SR-71 Blackbird. If you ever watch Star Wars, they got like a really shiny silver spaceship, and basically that's an SR-71 Blackbird. Somebody at Lucas Light and Sound thought that was a really cool thing, and I think that was a good decision because they really, if you've ever seen one, just even in pictures, they're radical. SR-71. They were built in 1964, but they were so insane. It's like every flight cost $1 million, and they did thousands of flights. Because the technology is so bizarre that you think, how do they do that in '64? You know, it's like the windshield wasn't even glass, it was quartz. and the windshield, the thing the guy looked through got up to like 600 degrees. And even when it landed, it was still 600 degrees, and they actually had some kind of a red marker around the windshield so that the crews would know better than to touch that thing after the plane landed. And which is silly, because these guys, nobody touched an SR-71 unless they had like top secret security clearance and all that. They knew that if they touched the windshield, their hand was going to burn off, so they didn't do it. But SR-71 would fly, what's the highest? They broke a record. They couldn't do it all the time. 16 miles. 16 miles up. So commercial, there's me again, right? Here's my brother. Commercial aviation is right about here. The world's fastest produced plane, which is no longer produced, could fly there. That's 16 miles up. Remember, this is 250 miles up. And it's going, where's the speed? The world's record. They actually have a dozen different world records depending on which direction it's going and all that. 2,242 miles per hour. It would still take, what does that come out to? It would take a lot longer than the International Space Station. So, I mean, here's the thing. I'm not making videos to try to convince flat earthers not to be flat earthers. They have an agenda. They don't have a belief. Somehow there's something that's motivating them to come here specifically to my channel, specifically to videos about the Bible, and try to cause disruptions or, engage in disruptive behavior, distract people from the truth, try to make people lose their faith. And there's nothing I can do to make somebody... I've already learned, you cannot reason with a person in a religion, and the flat earth religion is just like the religion of science, just like Roman Catholic Church, just like Hinduism. You're not going to change these people. This is not for them. This is for you. This is for the person that's being harassed by a flat earther so that you don't have to worry about what they say. There really isn't anything to back it up. Now, there's a few other things. This isn't all. I mean, this isn't the whole deal. Let me make sure I don't need any of this information here. Now, that's all just specs that I had to refer to while I'm shooting this really cool video. Man, I got to get a chair or something. This is hurting my back. All right, up here. Okay, why don't I want to talk about flat earth? I don't want to be thrown into conspiracy theories. Impossible to see. I think we covered that enough. Shadow of the earth. Here's something that's cool. If you go to flightradar.com, I don't know, the image is something like this. It's been a while since I've been there, so if I'm wrong, that's just the way it is. Here's this is America, that's Europe or something. This is the images you're going to see, right? So you might see a flight path that goes like this. Like we're going from Zanzibar up to Spain, from Spain up to London, and then we go from London to New York, right? And you can see in the flight path there's that slight curvature of Earth. Like if you're here, planes do just straight across. If you're down here, they go like this. But in general, you're just seeing straight lines. And that's the whole point I'm trying to make here, is that on flightradar.com, when you're looking at clicking on airplanes and kind of seeing their information, like what time they take off, what time they're going to land, where they are currently, the direction they're traveling, this is what they'll show you, right? If you go to Heavens Above website to look at the paths of satellites, the International Space Station, Space Telescope, all that stuff, you're going to see an image like this. My marker running out. Get a brighter marker in case y'all can't see that. One of the things people have been saying is that if my videos would improve. Well, first off, I had one subscriber saying you need to get one of those microphones that'll connect to your shirt, and I put that. It's in my beard. That's why you don't see the microphone in the way anymore. Another thing that's come up, and it's come up a couple of times, is that I need to put the screen a little closer to the camera, and I zoomed in, so it looks good. And then everybody's saying get some darker markers, so I may have to do that because these are they're a few months old. You saw when I first introduced this board. All right, this would be heavens above. That's what they'll show you, and you say, okay, I'm at 42344. Or you can give it gives you the option of putting your exact address in, but it's still only going to show you the same thing that they would show anybody in your zip code. But what you're going to see, like, it'll just show this for a flight path, because you're only going to see this from where it starts to where it ends, and you're not going to see it going all the way across the screen usually. In fact, I can't remember ever seeing that. Which makes sense because that would be past the visual horizon. But they give you an option of looking at like a full 24 hours of the flight path for a satellite. And I never thought about this before, and probably that's why it's good for me to share this. But you'll see a flight path that looks like a sine wave. And I don't know that they give that to you for every... Can you see that? Make sure that you can see that. And I'm not joking this time. I really want to make sure you can see that. Yeah, they don't give you this for every satellite, I don't think. But the big ones like the International Space Station or the Hubble Space Telescope, you can see that. And I'm looking at that and I'm thinking, well, that ain't right. These things don't have motors on them. How in the world is a satellite making all these complex turns in its flight path? I mean, when I go to flightradar.com, flight paths look like this. So, I would expect if flightradar.com is showing paths that look like that with these airplanes, then that's what a path should look like for a satellite, right? This is why I'm like a code breaker. When I look at something like that and it bothers me, I just keep thinking about it. I go, wait a minute. Something clicked. The Earth is spinning on its axis, right? So, airplanes don't worry about that. They're terrestrial. They fly within our atmosphere, which means they're flying, basically, they're ground-based, even though you don't think of them as ground-based. Because like I said, gases are just as real as liquids. Liquids are just as real as solids, and it's not our Earth that's spinning. It's the entire Earth system. That means the oceans are spinning with the Earth, and that's the thing that flat earthers will tell you is like, well, if the Earth is spinning, why doesn't the ocean just pour out of the Earth? Or, why do we not feel the wind? Or, there's all kinds of stuff that they try to use to confuse you. Don't worry about it. The Earth's atmosphere is just as real as the core of the Earth. The core of the Earth is probably spinning just like the Earth is spinning. The atmosphere is spinning. And I don't want to hear anything about what science teaches about the core of the Earth because that doesn't mean anything. But at Flight Radar, you got this. Heavens above, you got that. And that makes sense. Why in the world would these things do that? Well, I'm sure that you could, if you were to show this to a flat earther, I have never found a flat earther that would stand down. They're willing to fight to the death in defense of their religion, just like a Catholic's willing to die for the Pope. So, they'll tell you, well, they're just aircraft, right? So they fly funny. And but the thing is, I've never ever, my brother's not the only person I've done this with. I've done this with people all over the country, people I was in the military with, just because it's fun. I've been doing this ever since, when I got on the internet and found out you could track satellites, I just thought it was cool that you could actually go out there and track satellites. So I would do this. I would call friends and say, hey, man, what are you doing? Go out in the yard and take a look. I have never had somebody say, well, I don't see it because, oh, there it is, it's landing to refuel, right? These things are up there all the time. There are literally millions of people that are looking into the sky every night. Well, let's say thousands. I can literally say thousands of people are looking into the sky every night to see the space station, see Hubble Space Telescope, see satellites. And no one has ever reported seeing one of those things land or that one of those things was missing. Because that would happen. If somebody went out to look at Hubble Space Telescope and it wasn't there, they would say something. It would be in the message boards or whatever. So this stuff is real. Now we're going to talk about another thing that makes satellites different from aviation. And this is all stuff that you can check. Right? So, once again, we're going to draw the Earth. Here's the sun. And it's putting out sunlight. Well, what's happening, we'll just go ahead and draw a line right here. So if the sun is here, what's that line represent? Well, it represents day and night. This is nighttime on this side of the sun. I'd color that all black for you, but my ink would run out. Plus, it would ruin my eraser. So anyways, here's the sunlight. It's coming here. I guess a better way to draw this that makes it easier to see is draw the sunlight where it actually doesn't exist. So we've got sunlight hitting the Earth and sunlight going past the Earth, right? But this area is totally black. Now remember what I said, that solids are every bit as real as liquids. Liquids are every bit as real as gases. You cannot see dark. Like if you're right here and you're looking into the sky, say you're looking west, right? That's where, well, you're looking that way. What's the sky look like? It's black. You can see stars. You can see the moon. Okay, what if you turn around and you're looking this way? Because look, this is light, right? It's not that far away. That's light. Well, you're still going to see just dark. And the darkness is going to go on. You'll see stars if you're here, right? This is in daylight. If there's stars up here, you're still going to see them. Because the sunlight is hitting those stars, but it's not hitting anything else. This is a total vacuum according to the teachings of the empire, which sound logical to me. And remember, earlier we were saying that, why can you not see things that are 250 miles away on the Earth? Well, it's because of the particles in the air. There ain't no particles in this air. Now, if you're looking through the atmosphere, yeah, you got to look through some particles looking up. But basically, you're only looking through like ground level air at ground level. The air a little above that is a little thinner, air above that is a little thinner, air above that. Where planes are, the air is really thin. If you're up there and this happens, and it happens, I think a famous golfer had this happen to him. It's even a commercial airliner had this happen to him. They're flying along and suddenly they decompress. Now, it's not like these people exploded from decompression. What happened is that suddenly they went from having air to not having air, and so everybody just went to sleep. Or maybe even died because they just didn't have any air to breathe up there. So this, you don't have to go 250 miles before you hit vacuum. You're actually getting pretty close to vacuum just a few miles up off the ground, 10 miles up. If you're 10 miles up and your aircraft decompresses, you're going to pass out because there just isn't hardly any air up there. So when you're looking out here, there really isn't anything here. This is like a vacuum. Right here at ground level, it's just like what you're used to, but a little bit above ground level, things change. That's why in the evening when the sun goes down, you can still kind of see your way around even though you can't see the sun, because the sunlight that's hitting here is actually still hitting the Earth's, on the Earth's atmosphere over here, just around this part, is being hit by the sun, and it's diffusing around here. So, even though the Earth or sun has gone down, just the light hitting the atmosphere will kind of diffuse out around here to some extent. I don't even know where that stops, but you know that in the evening when the sun goes down, everything doesn't instantly turn black. Okay, so say you've got a satellite here. This is different from commercial aviation. If you're in this area of the Earth and you look up, you'll see a plane because you'll see the running lights. But if you can see, depending how far you can see, that's how far you'll see that plane. If you look up at an airplane, it's passing by, you're going to see nothing but running lights. But if you look through a pair of binoculars, you can see the shape of the airplane. If a satellite goes by and you look up with a pair of binoculars, the satellite's just going to look like a little dot of light. When you look through the binoculars, it's just going to look like a little dot of light, maybe a little bit brighter than what you could see without the binoculars. But there's a difference in when the lights on an airplane come on and when they turn off, and when a satellite's light shows and when it stops showing. If an airplane is in here flying and you followed it, you would see those flashing lights all the way from there to there. And you can test this. If you go out at night, what does it take? Like 5 minutes. Unless you're way out in the sticks, you're going to see a plane going on over like at least once every 5 minutes, and you'll see those lights flashing. And you can follow it with binoculars, and the lights never go out. They just get farther and farther away until you can't see them anymore. Well, with a satellite, it's a little bit different. Remember, the satellites are up here, and so you've got, and they supposedly, this is according to Teachings of the Empire, satellites do not have lights on them because satellites, all the energy that they produce ends up getting used for their instruments, like send back scientific data or for GPS signals or something. They don't really waste a whole lot of energy on lighting. There's no reason for lighting. These things are not dangerous. It's not like somebody's flying around up there and needs to be able to see them. So when a satellite's in the dark, like right here, you can't see nothing because the only thing that's lighting it up is the sun, right? So let's say, once again, this is like a microwave size thing, right? The sunlight is coming over here and it's hitting this side. And so if you're over here, you can see that satellite perfect. But if you're down here on the Earth, you ain't going to see nothing. You're not going to see anything because, the sun is really bright to start with. This is not going to be big enough to even leave a shadow on the sun. And this side is not being lit up, right? And this is a very important thing to keep in mind because it's very simple, easy to understand. And it's proof that, in fact, satellites are not aircraft. This satellite comes around to here, right? Now, if you're down here on the Earth, right here, you're looking up, you're going to see that satellite. Let me do a close-up drawing of it. A little bit better. Something that you can see. Might be able to use that picture of the sun. I'll leave it there. I hope you can see that. But anyway, sunlight is coming. Once again, all of this part of the Earth is in the dark, right? So the satellite is coming over the Earth. It's right here. You can't see it because this side is lit up over there. That side's lit up. That side's dark. You can't see a dark object in the sky, especially like in the daytime. You can't see stars in the daytime. You can't see a lot of stuff you can't see because the sun is just so bright. But what happens when the satellite's over here? Well, now sunlight is hitting that part of the satellite. So if you're on the Earth here and you're looking in the sky, you're going to see a satellite. Now, a satellite is moving just as fast as a space shuttle or whatever. So you could probably watch that thing go from as soon as the sunlight is hitting it until it gets in here. Because what happens when the satellite passes over here? Well, now it's in the dark. So that's why when you go out at night and you look up at a satellite, it will light up and it'll stay the exact brightness for, say, 10, 15 seconds, and then it disappears. Because what you're seeing is the angle of the satellite get to a point where it's reflecting sunlight on you, and then it's entering into the nighttime sky. So for that little bit of time, you can see a satellite. You can't see it any past that. And I've done this. Look, I've looked at hundreds of these things going over just because it's something to do, and I'm always outside. And they never fail. They always operate like that. Airplanes always, you can see them until they get too far away because they're working on artificial light. Satellites are depending on the sun, and so that's the way they work. And once again, this cannot happen with commercial aviation because, remember, the Earth is big. A satellite that's up here can catch the sun. If we're talking about commercial aviation reflecting the sun, it's only going to be able to do that for like a second because it's so close to the Earth that by the time it passes into the Earth's shadow, it's already out of the light of the sun. you know, it's not sitting way up off of the earth where it can reflect sunlight. Anyway, you see, that's like, what is that so far? 29 minutes. I mean, 29 minutes to discuss just this one aspect of flat earth. So that's why we're not going to make a long draw. And that's a good explanation. You know, if I'd have left any of that out, you may have doubts. So we're going to discuss all the different aspects of flat earth and prove to you that you absolutely, for a fact, do not need to fly into outer space and look back at the earth to tell whether or not the earth is a sphere. These are things that just a simple person living in a straw hut could do. Oh, well, you know, if you're in a straw hut and you have an internet connection, you can do this. Oh, well, more flat earth coming. And if you don't want to survive, don't listen to me. Mess my board up with this foolishness.